So the first thing we do is what? I guess maybe I should ask you some questions. What's the first thing we do like in a problem like this one?
You balance lefts, rights, ups, downs, counterclockwise, clockwise.
Okay, so the first thing we really need to do is look at the supports.
Okay, wow.
Supports we have.
Yes, that too,
So,
I suppose.
The support at C is what?
Pin.
That's a pin.
Yes.
Yeah, it's a pin.
Yeah, pin and roll. I forgot the names of them real quick.
Doesn't have the little wheels on it, then it's going to
Yeah.
be a pin support.
Yeah.
So since that's a pin support, we're going to put a force like here and a force like here. We're not going to assume we know which way they're pointing right now.
Yep.
So we're not going to put an arrow onto it. Okay. And the one at A is a roller support. So all it's going to do is, keep it from moving up and down.
Yep.
But it is allowed to go kind of back and forth. Right?
Mm-hmm. Yes.
Okay.
Yep.
Hold on. I'm trying to get my kids quiet.
I'm recording right now. Jeez.
Yeah, I know. They're playing Fortnite or something. All right. So that's what we're starting with. That's what we have. And we're going to try to figure out what some of those forces are. Mm-hmm. And so the first thing we're going to do is we're going to do ups and downs, lefts and rights, and torques. Right?
Yep.
Mm-hmm.
Okay. So let's see. I probably should have practiced this problem before I use it as an example.
No. Well.
This one over here, the one to the left, there's nothing to balance that out at all, right?
Yeah.
There's nothing going right or left anywhere else on here. Mm-hmm. So that means that we don't have to worry about that. That's like 0.
Yeah. So
we can go ahead and erase it right away. So that's kind of something we know. Okay. Downs, we have, downs, we have, 7.5 total?
Yes.
Right? 4.5 and a 3.
Hopefully.
And then ups need to equal 7.5 if both of these are ups, which they're going to be. So, okay. So what we do to figure out that everything is we're going to do torques, and we're going to have to decide where we want to put our reference point, right?
Yes.
And it doesn't really matter on this one because there's only 2 unknowns. If I had like 3 unknowns and I could put the reference point at a place where there were 2 unknowns, that's where I choose, because anytime I put a reference point on there somewhere, I don't have to deal with any of the forces that are at that reference point, right? Mm-hmm. So I'm going to go ahead and just use C as a reference point, and we're going to figure out the clockwise torques and the counterclockwise torques around C. Okay?
All right.
So this force here, we don't have to worry about at all.
Yeah.
Right? Are we good?
Yeah. Yeah.
Mm-hmm. Stop me if you have questions.
All right. Got it.
This is difficult stuff, and it's like almost impossible to teach online. So
yeah. That's unfortunate timing.
Very unfortunate timing. That's all I could think about was like, man, I really wish I would have pushed and at least did this before, because everything else the rest of the year is cake. I mean, obviously the last 3 units I made online.
We've already done them. They're really easy. Yeah.
All right. Well, you can take those tests anytime you want, by the way.
Oh, they're open?
Just let me know, and I'll open up a test.
Oh, okay.
So you can do it. So
cool.
Okay. All right. So this 3 kilonewton force here coming down like that is going to be a counterclockwise, right?
Yep.
That makes sense. It's gonna rotate down this way. Okay. Mm-hmm. So I'm going to put in the counterclockwise column. It'll be 3 times how far over is it?
1.2.
1.2.
Okay. All right. And then this one over here, this 4.5, is also going to be going around this way, right? So it's 4.5 times
3.6.
3.6.
Okay.
Have they invented styluses that are like really nice?
Yeah. There's Apple makes one, but knowing Apple, it's like $800. You could probably like find some counterfeit one on eBay,
I'm just using this.
or maybe on Amazon. I don't know.
I know Ryan has one.
Well, Ryan has like a drawing one.
Oh yeah, he has a drawing pad.
Yeah.
I used to have a drawing pad, but the problem is with the drawing pad that I used to have, like a Wacom tablet or something like that.
Mm-hmm.
But I draw on it, but I got to look at the computer to see what I'm drawing. I can't do that.
Yeah.
I just draw like normal. So
that would hurt my brain.
Okay. All right, so that means that this force right here at A has to be going up, right?
Yes.
Yeah.
Jeez. My wife's dropping stuff in the kitchen. Okay. This force is going up at A because it needs to provide clockwise torque, right?
Yes.
Yeah.
So it's going to be whatever it is, force times 2.4, right? And those torques have to be equal to each other.
Yes.
Okay. So right there, we can figure out what the force at A is. So I'm going to take 3 times 1.2 plus 4.5 times 3 what is that?
6. Yeah.
Yeah, so that's the problem. It makes me
Yeah. It's the pen. Yeah.
Yeah, it's the print. Divided by 2.4, I get a force of 8.25.
I'm doing it.
I don't know
Yeah.
if any of you checked my work.
Yeah.
For free
I'm
handout.
busting out the
8.25.
calculator.
I'm not.
I got 8.25. Yeah.
I'm recording it. That's
Yeah,
my contribution.
8.25. What the heck?
Let's see.
Okay. Oh.
You get that answer or not?
8.25?
8.25?
Yeah.
Yeah.
Yep. Mhm.
Okay. All right. Okay.
Cool.
So that's 8.25 up
Mm-hmm.
right there at that one, right? So I put that in the up column.
Yep.
So that means actually we need some more down force.
Yes.
It looks like, right?
Yes.
3 times. I want to make sure I'm doing this right. 3 times 1.2, and we did 4.5 times 3.6. Okay, so we need some more down force. How much more down force do we need?
0.75, right?
5, yeah, minus 7.5, right?
Mm.
0.75, and so this
Yes.
right here
Quick maths.
must be a down force. Okay.
Okay.
I hope if we're doing it all right.
We'll find out later.
Yeah, we will. Then I'll have to just
We'll have to
edit the recording.
yeah, record
Yeah.
a new one.
I've had to edit so many of my recordings. I get halfway through the problem, I realize, oh man, I totally did this wrong.
You could dub over the numbers, like, and then we get 0.75.
Yeah. It's like, how'd that happen? All right.
What? But he wrote
okay,
0.89. What?
That's how you start, and that's
Yeah.
the big thing. Starting,
Yeah.
you got to get all your external kind of forces all figured out.
Yes.
Erase.
Wait.
Oh, what is it? What's happening? There?
Oh, I think you were erasing the erase from earlier.
I was. I didn't know you
What?
could do that. That's
Because he had the line going to or like to the side of the pin to see like, oh, we might have a left or a right there, but then he erased it.
Oh.
And now that he's
Whoa.
Whoa.
he's erasing his erasings.
Oh, man, this is like
Not
Just-
how erasing is.
Just color it over white, I guess.
I
weird.
mean, isn't that the
stuff,
same thing as like smudging an eraser that already has lead on it?
I guess.
Basically, who knows? Who
Really
knows?
strange. Okay. So now comes the part that you're asking most.
Yeah.
About, I think, is how to do the internal kinds of things.
Yes.
So, we just try to find a place to start with the least amount of members as possible.
Okay. So like not A.
I would not do A
Definitely not A.
or D. I would not be looking at those
Yeah.
places at all. So
It's probably F. I don't know. F or
do
C?
We could do F, or we could do C. Let's go ahead and start at C.
Okay.
That's where we're kind of focusing around anyway. So, so what I have here is, I have this member here. I got this member here, and then I have 0.75 going down, right?
Mm-hmm.
So the forces all have to be balanced around point C.
Yes.
So it's always ups and downs and lefts and rights around point C. We don't have to worry about torques and that kind of stuff. Okay.
Yep.
So I know that I need an up force of 0.75, and this one here, this member here, is not going to be able to provide that, right? I mean, that's either going left or right only, right?
Mm-hmm.
Mhm.
This one here, though, is at an angle, so it's either going to be an up and an over this way, right? Or
Yep.
it's going to be a erase.
Don't erase anything else.
it's going to be an over and a down, right?
Yeah.
Those are the two options, right?
Yeah.
For that thing. Okay, so which one does it have to be?
Has to up and then over.
It has to
over.
be up
Yeah.
and over, right? It has to be that. And I know that this up needs to be 0.75 to balance that out.
Yes.
Yes.
Okay. Now what I know now then is that this one down in here is going to go to the right.
Yep.
I know it's going to go to the right because it has to balance out this thing going to the left.
Yes.
Okay?
Yep.
All right. So down here in this in BC member, I know that this is coming into the right, and then over at the other end of the member, I the opposite arrow. Okay, so once you know how the arrow is going point, like I know this is going into the right towards C, then over at B, I can just draw the opposite arrow.
Yeah.
Okay? And this is going to be, so if the arrows are pointing outwards in the member, that's what? Compression.
Negative. Well, it's compression.
Yeah, it's compression, and so it's going to be a negative. So this is going to be a negative here when we figure it out. We haven't figured it out yet, but it's going to be a negative something. Okay? All right, and this thing here in DC, the member in DC, is going to be coming like this, right?
Yeah.
Because it's going up and to the left, so it's going to be going up like this,
Mhm.
which means I can come up here to D and I can draw in like this. Okay, you do the opposite, the same arrow opposite, on the other end of the map. And so these two arrows are pointing in, and so this one is a
Tension.
This one's a tension, so it's going to be a plus something once we figure it out.
Yes.
Let's see. Yeah, one of the things we probably should have done earlier also is
Angles.
figure out an angle, right? We didn't figure out any angles, did we?
No, we did not.
Okay. So to find out this side, I need the angle in this triangle, right?
Mm-hmm.
Okay, and I'm just going to redraw the triangle over here. And so here's the member. Okay, we're trying to find this angle.
Yep.
Now I know distances, how we find the distances. And I know that this distance over here is 0.9, and this distance up here is 1.2.
Mm-hmm.
Right? Does everybody agree
Yes.
with that?
Yes.
Yes.
Okay. So this angle, the tangent of that angle, would be the opposite side, would be 1.2. Now, keep in mind, this has been confusing in the past for people. I'm not this and this, I'm not using forces right now.
Yeah.
Right? I'm not using the forces. I'm actually just using the distances, okay, to figure out the angle. Then we'll use the angle to figure out the forces on this is 0.75, and we'll try to figure out what this other one is.
Yes.
Okay. All right. So 1.2 divided by 0.9, and then I'll do inverse tangent. Make sure your calculators are all, none of these are right.
Yeah, always in degree mode.
You got to be in degree mode, yes.
Yes.
Divide by
All
0.9.
Sorry, Discord cut out there, so that didn't show up on the recording.
Shift tangent. Okay, so this is this angle in here is 53.1.
Yeah, that's what I got.
Okay. So 90 minus 53.1. This other angle in here, because we might need it, because this is all symmetrical. So that angle in there.
Yeah.
I have like a part on my iPad that doesn't really want to write.
Oh.
I think it's Doritos stuff or something.
You munching on some Doritos?
Not me. This is my son plays with this thing all the time.
Oh, okay.
I have to borrow it from him to do lectures. So
It's
Oh.
full
Okay.
of science now.
all right. Okay. So now we can use this angle of 53.1 in here to figure out what this other side is, because tangent of 53.1 will equal that opposite force over the 0.75, right?
Mm-hmm.
Does that make sense?
Yeah.
Okay. All right. So it's going to be 0.75 times 53.1 tangent.
It's 0.9999999.
Yeah, so it's basically 1.
It's okay, so it's 1.
Yeah, I'm just going to call it 1. That's probably good enough.
Yeah. I've noticed there's a decent tolerance on the answers for the E-Lab.
There is. I put it. I had it's a special kind of a question you can do in Moodle. like I don't know what it's called exactly, but anyway, I can put in like tolerance and I'm like,
Yeah.
like plus or minus 5 or something.
Yeah, because there was a question. I was like, all right, it's like 2 or something, and I watched the video, and you're like, it's 0. I'm like, well, but I got it right. What the? So I typed it. I'm like, oh, it works for either one. What the heck?
Right. Yeah, there was that one problem. It was
Yeah.
like, 1902 this way and
Yeah.
1900 this way, and so basically the idea was they were supposed to kind of come out to be the same.
Yeah.
But depending on your calculations, they might have been off a little bit. So I just put in like the answer is like 2 plus or minus 2.
Yeah.
So, okay. So this one's 1 right there, and if you have Relab open, I think that would work.
Yeah, I think
For
and it's
DC would be 1.
Okay. No, wait. Because that's just the left force. So you have to take Pythagorean's theorem, right?
You're right.
Yeah.
You're right. Yeah, I'm sorry. That would work for BC because now
Yes.
we know down here this has to be negative 1.
And that'd be okay.
Right, because this is coming in like this. It has to be equal to that, right? Yeah,
Okay.
I misspoke. BC should be negative 1. That should work.
Yep.
Now for DC, we got to use Pythagorean's theorem, right? So 1 squared plus 0.75 squared square root should be like plus 1.25.
Let's see. 1.75 squared.
Actually, I'm surprised 1 didn't work with my plus minus.
1.25.
Yeah.
Is that good?
Potentially.
Okay.
Did it work? It worked.
Yep. It
Yeah.
works.
Okay. So a lot of times after you do that very first, so we just basically did the joint C and we did all the members around it. So we start moving on to new joints. And a lot of times when you do that first one, there's a lot of other things that kind of just fall into place real quick.
Okay.
Like if you go to B, the only possibilities is something going up and down and another one going left or right, right?
Yeah.
So we know that AB has to be like this.
Yep.
Right? And it has to also be a negative 1.
Okay.
Right? And there's nothing to balance out the one going up, right? So BD in there, that actually has to be 0.
Okay.
I don't think DB is or BD is on the.
No, it's not on the thing.
Yeah.
Oh.
Yeah, I probably
So-
didn't put it on there because it ends up being 0.
So you just ignore the 3 kilonewtons going into D? You like just focus
we're
on
gonna
B.
use that 3 kilonewtons.
Well, yeah.
It's going to be balanced out by, this
Yeah.
one and this one.
So
right?
since there's nothing going into B, you just ignore that for now.
No, I know that this has a 0 force in it because there is no way to B.
Yeah.
Does that make sense?
Yeah.
Okay. So I know that this force in here has to be 0. So it's not going to be providing any force onto D either with this member. This member has no tension or compression in it. It's kind of balanced out around everywhere else and all the other members, and so that one is basically just kind of connecting those 2 points.
Gotcha.
Force stuff. So okay. Let's go over and look at F. A and D still have a lot of things coming out of it, so let's just go over an A and at F, and then kind of work over towards E, and then we'll probably be good for A and D. So if we go to F, let's see, can I erase that now? All right. So again, F is a lot like A was, right? We have this FE, which is going to go left or right, but we know that FA, it has to be going like over this way and up, right? We know it has to do that because this up here is the only way we can balance out this down 4.5. Yeah. So this one here is going to be going in like this and then down like this. So this is going to be a compression, right, for FA.
Gotcha.
Okay. And this one's going over to the right or left. So that means this one, FE, needs to go like this and this, right?
Yep.
To balance this out. This is going to the left, so that has to go to the right. So that's going to be a tension in FE. Yeah?
Yes.
Okay, all right. I can't see your expression, so I have no idea.
Blank.
Normally, I can kind of see like, okay, no one understands what I'm talking about. So, okay, so
Turn on our face cams if you want.
no,
Have a Zoom meeting.
oh boy. Okay.
Zoomers.
This angle right in here is the same angle as the one that was down in here, right?
Yeah.
Yes.
Okay, so it's all symmetrical. What was that angle? That was 36 point, basically 37 degrees.
Yeah, 37.
I have enough tolerance built in. We can kind of round some of these things off a little bit. So that's 37 degrees. So I can figure out this other side over here. I can do tangent of 37 equals the force that we're looking for over 0.9. Oh, no, not over 0.9.
Yeah. 4.5.
Over 4.5.
Yep.
See, I messed up there. I did the distances instead of the forces.
Yeah.
Okay, so the force over 4.5, because I know that this up force has to be 4.5, right?
Yeah.
Okay. So 4.5 times 37 tangent equals 3.4.
Just
Negative 3.4.
3.4. Yep.
Okay.
And so we automatically know that FE,
Yes.
we have an answer for FE, it's 3.4.
Okay.
That one should work in the E-Lab if that's the one you had to have. I'm not sure.
So yeah, plus 3.4.
And it would be a plus 3.4.
That is not. Wait, FE?
Yeah, Effie.
FE,
I'm not getting that.
not
Maybe.
taking it?
No.
Well, that's not good.
What did you type exactly?
Plus sign 3 period 4.
Okay.
And I don't have any units on these things, right?
No.
No.
Okay.
Mm-mm.
Interesting.
All right. Let's see.
Well,
4.5.
what happened
Okay,
here?
let me check here.
We have our best minds on the
Wait a
case.
minute. Wait a minute. That. Oh. No.
Huh?
Oh yes. I know what we did. I'm not going to tell you.
What?
Oh no.
You tell me. What did we do?
This is just bad teaching.
That's why I'm here.
Yeah, it's pretty obvious.
Is it supposed to be the
I just
inside
said it
angle that's
out loud, so you
37?
just all accepted it. You know
I
what
think-
it is?
Something with the angles.
It is.
Yeah, is it the inside angle? It's like inside the actual truss system that's supposed to be 37?
Yeah.
Right, yeah.
Yes. Right.
Oh yeah. Yep.
Yeah, it's alternate
Yeah.
interior angles means
that one.
Yeah.
we have two parallel lines.
Yeah.
This is 37, so this is 30.
Yeah, I was
Yeah,
thinking
okay.
it, but I was like, you know what? I probably just misunderstood.
No, I'm pretty much going to be wrong like a lot of times.
Okay.
So, question
Okay.
everything I'm saying.
Got you.
Question all.
Got you.
authority.
So it's 90 minus 37.
Yeah.
So it's
so it's
So
53.
53.1
Yeah.
we had over
Yeah.
there. Yeah.
Okay.
Yeah. I don't know why that was really bad. Really bad. Totally embarrassing. I might have to edit that video.
I will upload the full thing. You can't hide your mistakes.
Alright, so I got 6.
Yeah, I also got 6.
Does
That's
it work?
right.
This
Uh,
it
yeah,
works.
it works.
Okay.
Okay.
Cool.
There we go. That never happened.
3.1.
And welcome back.
Well,
To you guys, it felt like nothing, but we just went through 5 minutes of torture.
Right. Yeah. You'd be surprised how many of my videos are like that.
Yikes.
Like all of a sudden, a little glitch. I mean, almost all those ones up above, there's a little glitch, and that means that I just probably deleted like 20 minutes.
Yikes.
Oh man, some of them you can almost seamlessly, erase the mistake, and
Yeah.
so, and sometimes if I knew I made a mistake, I kind of like start over in that place, and then I just know to go back and delete that section of the video. So, but problem is here I can't do that. So
I just you scream really loudly, so I make a spike in the audio. So then I'm like, what was that? And I go back, oh, right, delete that part. Remember now.
right, yeah.
so does that mean that ED is also plus 6? Whatever.
Yes, yeah, because it's going to have to go like this.
Okay.
right? And then this here again has no way to balance out, so
Yeah.
support thing to it says 0 also.
Yes.
Yeah, these are plus 6s, right? Plus 6.
Okay.
Okay. So
Okay.
let's see. This thing's not right here anymore. This is a 6, right?
Yep.
Okay. Yeah, and this was a 4.5. Okay, so we have to do Pythagorean's theorem on this. So 4.5 squared plus 6 squared square root is a 7.5. This is a compression, so this is going to be a negative 7.5 in here. Is FA.
FA negative 7. And that works, yep.
Good.
So now we have is AD.
Do we need AD?
Yeah, we just need AD.
Okay. So that's the last one we got. So we can do it at D or we can do it at A. Either way is going to be okay. Let's go up to D, I guess. And I'm going to erase a little bit here. So C over here, down here at this point, it's up 0.75 and over 1.
Yeah.
Okay, so at D, all that is reverse, right? It's actually going over 1 over the right 1 and down 0.75, right? Okay, so I'm just going to erase that real quick, and we're going to go over 1 and down 0.75. So we kind of know what this truss here is doing, right?
Yeah.
Okay, so so this is where it gets kind of tricky. This down 0.75 needs to be balanced. Where's the only place it could be balanced? Because this one's 0 in here.
Yeah.
With the A to D truss, if it just
It has to be the
Yeah.
AD, right? It has to be the AD. So this thing here has to be coming up. I wish this was bigger. This has to be coming up at 0.75.
Yeah.
Right? And then it has to be going over, right? And what is that? What is that one over?
1.
5.
Yes. You're right.
Let's go, because you have to cancel out your lefts and your rights. And since it goes to the left 5 more than it does to the right, you have to get it to go right more.
Very good.
I think.
Very good.
That wasn't.
This is 6 to the left. You have 1 to the right. You still need 5 more to the right. So that is a 5 in there.
Okay.
Okay. And so that's how we get everything balanced all around D. Does that make sense? So this is 0, right? See, this is tricky stuff. It's really I think they should put truss problems like in the paper, like Sudokus or something. It's incredibly challenging. It takes a long time to get all the way around it. So yeah, the 0.75 down will be balanced with this one up, and then this one over the right needs to be 5 because I have 6 to the left, I have 1 to the right, I still need 5 to the left.
Okay.
Do Pythagorean's theorem on that.
I got 5. Yeah, I got 9.
9. I didn't get 9. I didn't do it.
I got 5.
You got 5. Okay.
What?
Yeah.
Okay, let me try this.
Oh, I did 7. I did 7.5.
Oh, 0.75 squared.
Yeah.
Yeah, I got 5.1 essentially. So 5.
Yeah, 5.1.
Okay, that time I got something totally different.
Oh.
Oh, I did 25.
And it should be a negative.
Yeah, I got a 5. And so it's coming into the D and it's coming into the A. That's a negative 5.
Yeah. Let's see.
U-E-D.
That is not right.
That's not right?
That is not right.
That's not right.
The QED came too early.
Oh, no.
We celebrated too early.
Oh, man.
Okay.
Delete the recording after restart.
I'm erasing Q.
Do we have to do anything with the 3 kilonewtons, or is that just?
Oh!
So do we have to balance out? Do we have to balance those out? So is it an up force of 3.75?
3 kilonewtons. Oh man.
Yeah,
Is that what it is?
Totally
3
did not
minus
see that. See,
0.75.
it wasn't in blue, so I.
Well, no, wouldn't it be plus because they're both going down? So you'd have to have an up force of 3.75.
We have 3.75 going
Okay.
down. So this over here has to be a 3.75 going up.
Got you.
Alright.
Yes. So it should be 6.25. The final answer. Negative 6.25.
3.25 squared plus 5 squared
So
is
6.25.
6.25. Let's try this.
Okay, now the QED.
Yep.
No, not yet. Not yet.
No, I'm
Okay,
I'm
now
confident.
we're at the QED.
All right, all right.
We got a QED?
Yes, it
Yeah,
was
we have a
6.25. Okay.
Doing that in orange.
Wow.
Anyone did that.
It seems like an orange kind of QED to me.
Oh man, that was actually a pretty rough problem. No wonder I haven't done it yet. So I'll try and just pick all the easy ones that I thought would be fairly easy that I could just do and show how to do it. So.
Well,
Okay.
All right.
Great
That-
job, team.
That was
Make
fun.
more sense? Or?
Yeah. Just kind of going through the process.
Yeah.
A little more in depth was
I mean,
nice.
I don't. It's it's not easy. That's
Yeah.
So,